Hi, welcome to our math. Today I'm doing a series of videos on variation, and I really like this problem because it's not story problems, which often happens with variation, but it's showing kind of the four common types of variation problems with the same numbers and just showing how to set each of them up into a basic model. So it says just find each of these four. I know you only see three. We'll get to the fourth when I scoot the paper up. So if y is directly proportional to x, that means we're doing y equals k times x. K is our constant of proportionality in every variation problem. So then we say, we always get one example, 20 equals k times 8, divide by 8. So if k is equal to 20 times 8, we need to reduce our fraction. K is equal to 5 halves. So we have y equals, I'm going to write 5x over 2. No, I am not going to decimal. I only go to decimal in 3 situations. 1, application. I just said we don't have an application. Application means story problem. 2, the original problem has a decimal. These are not decimal numbers. I am staying in fraction. 3, the directions specifically say round to so many decimal places. None of these tell me to round. I am keeping everything as a reduced fraction. Fraction means precision. If you are in a math class, your answer should probably be left as a fraction, not a decimal. All right, y is inversely proportional to x. Direct means it's like they're on an elevator. They go up and down together. You can almost see the elevator there. Inverse, y equals k divided by x. It's like a teeter-totter. When one goes up, the other goes down, and you can see one is up and one is down. Direct, up and down together. Inverse, one goes up when the other goes down. K is your constant of proportionality, and it is the constant in every inverse or proportionality question. 20 equals k divided by 8. This time I will multiply to get k by itself. K is equal to 160. Y equals 160 divided by x. Y is jointly proportional to x and the square root of z. Jointly proportional is the same as directly proportional with more variables on the right-hand side. So if we can do directly proportional, we can do jointly proportional. If it is jointly proportional, there's more people on the elevator. X is on the elevator, as is the square root of z. That's all. Jointly proportional, more things on, more people, more variables, more items on that elevator together. So I'm going to scoot this up, and we're going to lose the first two parts because I want to get everything else on screen. So y is 20, x is 8, and z is the square root of 4, which we hopefully know is 2. So 20 equals k times 16. I'm going to divide by 16, and you can probably guess that if k is 20 over 16, I'm going to reduce this so that k is 5/4. And I'm either going to write this as y equals 5/4 x times the square root of z, or you could write y equals 5x times the square root of z over 4. Both of these are fine answers. They're the same. They are the exact same answer. It just depends on how you want to write your answer. All right, and last, this is called combination variation, combined variation, because you see the word direct and inverse. You get it all in one problem. Y varies directly with x and inversely with the square root of z. Before you go on about rationalizing the denominator, we are not going to do that in this problem. That is a problem for a different video. We are just talking about variation today, and we are going to leave that square root in the denominator. We are not using a slide rule to divide. We have calculators that can divide by the square root. So you know what? We're not going to worry about that antiquated process today. All right, 20 equals k times 8 divided by the square root of 4. Hopefully we still know the square root of 4. Is 2. So we have 20 equals k times 8 times 4. divide by 4, and k is equal to 5. So y equals 5x over the square root of z. So there we have it. We have gone through and learned and seen an example of direct, inverse, joint, and combined variation. I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.